Okay, so today we're going to do the trendline demo file. And this is really to get our experimental data and to understand how the trend line or what trend is occurring with our experimental data. From this, we're going to graph three separate graphs, example A, example B, and example C. Example A will be graphed on its own sheet with blue diamonds, example B as green triangles, and example C as purple squares. So I've gone ahead and put proper plots together. So starting with example A here, we see that I've adjusted our bounds for our temperature to be from 360 degrees Kelvin to 520 degrees Kelvin. We've got our pressure, which ranges from 0 atmospheres to 4 atmospheres. Now we want to add our trend line to our data here that is presented by blue diamonds. And so I'm going to right click and go to add trend line, or I can click up in the corner of the graph, the little green chart elements addition, and say click on trend line, which will automatically default to a linear trend line, or I can head up to my design tab and say add chart element, go to trend line, and then choose what type of trend line best fits my data, or go to more trend line options. And so I'm going to click on more trend line options here. And so we see that when you do more trend line options, it defaults to a linear trend line added to our experimental data. And I'd say for now that this actually fits our data pretty well. Most of our points fall really close to our line. So I'm going to go ahead and display the equation on our chart. I'm going to kind of shift this so it's not overlaying part of the line. So I'm going to shift it just below our dotted line here. And then I'm going to come in and start editing my trend line. So moving over from the little bar graph icon here, I'm going to move over to the little icon, looks like spilling paint out of a bucket, to format my line. And usually with a trend line, to properly format it, we want to make sure that the trend line matches the same color as our data series that is present here. Make sure that our line width is something large enough or thick enough that we can see what our data is doing here. And maybe I want a single line, or I can go back to my dotted line, or maybe a short dashed line representing my data. And then here, for our trend line equation that is present on our graph, it comes in the form of the equation of a line, y equals mx plus b. And so we notice we've got our y and our x, but on our axes we have temperature and pressure. Temperature represented by the symbol T in units of Kelvin. Pressure, our symbol is P in units of atmosphere. So we want to go ahead and edit our trend line equation to include our variables from our axes. So our y turns into a capital P, our x into a capital T. And then we want to look at this trend line equation and say, what theoretical equation does that match to? And so based on the equations that we've worked through, this is probably representative, if it's a pressure and a temperature, of ideal gas law, PV equals nRT. And so when we have that theoretical equation of PV equals nRT, our y-intercept in our equation really does not exist. And so I'm going to actually get rid of that altogether so that we end up with a trendline equation of P equals 0.056 times T as our theoretical representation of our experimental data. And so this is saying that our pressure is equal to this constant, and that constant represents our N times our R, which is our gas constant, all over our volume of our tank. And then that constant is multiplied by our temperature. And so our relationship is based on these pressure and temperature here, with our constant being NR over V. So then I'm going to come in here and edit this trendline equation fill. So I'm going to come in and do a solid fill on this. And you can do this where I'm going to make it on a white box. I'm going to come up to the Home tab, and I'm going to make sure that the font size is nice and large so that it's easily readable on my graph. I'm going to make it in a bold font. Then I'm going to change that font color to match the font or the color of my line here and my data points. And then I'm also going to put a border on my box that matches the color of my data series. And so now I'm actually going to increase my width to 1.5 on that box so it kind of stands out there. But now I've got my equation placed pretty close to my data series here and the line that it goes with. I've replaced the x and y values of my trend line equation with the symbols from my ordinate and my abscissa, or my x and y axes. And then here we do have a small number. You may want to round this to 0.006. We just want to make sure that this has a reasonable value, and maybe this would be represented as 5.6 times 10 to the negative 3 instead of, so we could put this into, instead of a number, we can turn it into scientific notation or engineering notation to better represent the value here. And so this is kind of how we do our trend line. So we add our trend line, we add our equation, we adjust our equation to match our axes with our variables, and adjust the numbers to be appropriate decimal-wise, with that trend line equation being close to our line for those that want to read it. If there were multiple series on here, you're going to want to place them so that they are easiest identified to the line that they correspond with. So let's move on to example B here. So I'm going to click on my example B graph. And so in this case, I'm going to come in here. I've got my green diamonds from my experimental data set. And this is looking at volume and radius. So I'm going to come in and add my trend line, again displaying that equation on my chart. But we notice this defaults to a linear line, which adjusted my axes here. But in reality, a linear line doesn't fit this data very well. So what about an exponential? So that at least curve gives me a little bit better fit. So I'm closer on these interior data points of my series, but this endpoint is pretty far if we were to look at the difference between the actual value and the experimental value. So maybe we look at a power, and that power equation definitely gets us closer to all of our data points along this line. So I'm going to come in, now that we've determined that this is a power, which we should have kind of anticipated that's a power based on that this has a volume and our units are centimeters cubed in relation to a radius of centimeters. And so I'm going to come in here and again, I'm going to do my line. I'm going to change its color to green to match my data series. I'm going to change to maybe long dashes, increase the line width to 3. And then come in here and edit my, so I'm going to put my equation in a font size of 18 and make it bold. And this time I'm going to do a solid fill of green to match my data series. But in doing so, I'm going to turn my font a white color so that it has good contrast. And then again, I'm going to come in here and edit my ordinate and my abscissa symbols, and then adjust my decimal places. And so here I took this down to 12.5 because we normally work with 3 numeric values with a decimal that falls in between those, or turning it into engineering notation based on that. Now coming over here to my R and looking at our power value here. So we've got 2.027. Theoretically, really in any power greater than 1, you are usually looking at a value that should be an integer. So in this case, I'm going to take this and round it to 2. So our equation becomes V equals 12.5 R squared for our trend line equation that represents the data that we have plotted here from collected data for our experimental data series. And then on my box, I believe it still has a border. So I'm going to make sure that that border is green and matches my data series. And then we'll move on to our third graph here, our example C. So here we have time and voltage on our plot. And so when we add our trend line, if I look at a linear trend line, again, doesn't fit very well. But when I come down to exponential, that fits my data series very well. So I'm going to come in and looking at my exponential, display my equation on my plot and start to come in and format my line. So I'm going to turn it purple again. Maybe this time I do a short dash dot and do a line width of maybe 3 or 4, just so that it's easier to interpret along this trend line. And then again, come in and edit. I'm going to make my font bold and then increase the font size again to 18. I'm going to do a solid fill that is white, and I'm going to do a border that matches my data series. Then maybe in this case, we also want our font to be purple to match everything else. And then lastly, we need to come in and edit our trend line equation. And you want to leave that for the last part of this, the fact that if you decide that, say, this exponential is not the best fit for your data, and you click on your trend line and want to change up what best represents, you can do that now. And as soon as you start to edit the trend line equation, that equation does not update when you go to change what trend line option you have. So editing your trend line equation should be the last thing that you do here. So I'm going to say that this is V for volts, and my little t, and then I'm going to round this to say 20.1. So my equation should read V equals 20.1 E to the negative 0.1 T. And I think that is everything that we do for our trend lines. So near placement to our trend line, editing our equation, which is what we leave to last, making sure it's on a white background so our grid lines do not show through, makes it easier to read our equation here. If you don't want your equation to match the text, you can always leave it as a bold black font because that makes it high contrast and easy to read. Otherwise, this is how we finish out our experimental data series to understand the trends that are occurring from the data that we collected.